then we'll continue from where we stopped last week. Last week we talked about areas of plane shapes. Areas of plane shapes, and we say that a plane shape is any shape that can be placed on a flat surface, while area is the amount of space an object or a shape occupies. So today we'll be looking at areas of rings and sectors of a circle. Areas of rings and sectors of a circle. On that, we'll be looking at the concentric circles. Now, concentric circles are circles which have a common midpoint or a common center. Concentric circles are circles which have a common midpoint or a common center. You can see two circles on the board but with the same center. This is the center for this and this is the center for the bigger one. Even if we have another circle, outer circle, you still have the same center. So we call this kind of circles concentric circles. Now, examples of objects that we use at home that have these concentric circles are our flat rings and our washers. Our flat rings and our washers. We'll be looking at how to find the areas of concentric circles like this. We have a flat ring on the board. If we notice, we can see that it has a shaded part. Now we say that the radius of the circle is any straight line that moves from the center of the circle to a part of the circumference. But here we have two circles. We have the first one, the inner one, which is the smaller one, and the outer one, which is the bigger one. And we have the smaller radius for the smaller circle. The straight line that moves from the center to the circumference of the smaller circle is our small radius, and we have our bigger radius here. This one, the straight line moves from the center to the bigger circumference. So we'll be looking at the area of a circle. We all know that the area of a circle is given as pi r squared. But here we have different radii for the two circles. We have the small radius and the big radius. So the area of the outer circle is given as pi r squared for big R. Since our radius, we use big R to represent our radius. So we say that the area of our outer circle is pi r squared, where R is the big one. And for the inner circle, since our radius here is represented with the small r, so our inner circle, the area gives us pi r squared with the small r. So the area of our shaded parts, that's the area of this region, will give us pi r squared minus the small one. That's for us to get the area of this shaded part, we find the area of the bigger one and subtract, and we find the area of the smaller one. We subtract the area of the smaller one from the area of the bigger circle to get the area of this region. And given as pi r squared minus pi r squared. Where for the bigger one we have the big R, and for the smaller circle we have the small r. If we factorize this, since we have pi common to both, we have pi into bracket r squared and big R squared minus small r squared. So we now use the difference of two squares. Using the difference of two squares, must have been taught in jss3. At a squared minus b squared will give us a plus b times a minus b. This is called the law of the difference of two squares. Now we have to use it to expand this. So that will give us pi into bracket r plus r, then r minus r. Therefore means that using the difference of two squares, this times this will give us our big R squared minus our small r squared. So we'll solve an example. A circular pond of radius 12 meters is surrounded by a path of width 2 meters. Find the area of the path. A circular pond of radius 12 meters is surrounded by a path of width 2 meters. Find the area of the path. Now we have our circular pond on the board. We have small radius and this is a big one. We are told that this is our circular pond. We are told that it has radius 12 meters. That means our small r is 12 meters. But it has a pathway of width 2 meters. Means that from this point.
Okay.
Alright, so we have the circular pond here, and our radius is the small r. We are told that it has a width. That means this pathway is our width, has a width of 2 meters. We are now to find the area of the pathway. What do? We apply our formula. The area of the pathway will give us area of the bigger circle minus area of the smaller circle. So we have pi r squared minus pi, that's the big R for the bigger circle and the small r for the smaller circle. Now, since we are told that it has a radius of 12 meters and this pathway measures 2 meters, that means the radius of the bigger one will give us 12 plus 2. The radius of the bigger circle will give us 12 plus 2. That's 14 meters. So we solve. We have pi into brackets. Our big R is now 14 plus our small r of 2. Then into brackets. Our big R is 14. Our small r is 12. Our small r is 12. Now we have our pi times 14 plus 12 gives us 26. 14 minus 12 gives us 2. We have pi times 26 times 2 gives us 52. 52. We now have our pi, which is 22 over 7 times 52. 22 over 7 times 52. And if we multiply that, it will give us 163.4 meters squared. 163.4 meters squared. Now let's just watch through it again. The circular pond of radius 12 meters is surrounded by a path of width 2 meters. Find the area of the path. We say this is the circular pond. The small circle represents the circular pond, and we say it is surrounded by a pathway of width 2 meters. So the radius of our circular pond is 12 meters. That is small r. Since we have a pathway of 2 meters, we add it to the radius of our bigger circle, which gives us 12 plus 2, that's 14 meters. That means the small one is 12 while the bigger one is 14 meters. We have to find the area of the pathway. And for us to find the area of the pathway, we find the area of the bigger circle, or we find the area of the smaller circle. We subtract the area of the smaller circle from the bigger circle. The answer gives us the area of this pathway. And we are told that we are given the formula on the board, pi r squared minus pi r squared, where we have big R and small r. Using the law of difference of two squares, we have this on the board. So we have already established that our bigger circle has a big radius of 12 plus 2, which is 14 meters. Okay, we have pi into brackets. Our bigger circle has a radius of 14 plus our smaller circle having a radius of 12. Then into brackets, our bigger circle having a radius of 14 minus our smaller circle having a radius of 12. From here, 14 plus 12 gives us 26. 26 times 14 minus 12 gives us 2. So we have pi times 52. Because 26 times 2, we have 52. The value of our pi is 22 over 7. We multiply this out to get 163.4 meters squared. Therefore means that the area of our pathway is 163.4 meters squared. Now we're going to look at sector of the circle. This sector of the circle is the fractional part of the circle bounded by an arc and two radii. You see, the sector of the circle is the fractional part of the circle bounded by an arc and two radii. That's what we have it as our circle. And by radius, the straight line start from the center. So, in the center of the circle, we have our two straight lines. So these two are called radii. We have a radius and a radius. So, this is our arc. So this region is read as our sector. You see, the sector of the circle is a part of the circle bounded by an arc and 2 radii. So this is the sector of a circle. Now, the area of the sector of a circle given as theta over 360 times pi r squared, where theta is the angle subtended at the center of the circle. So we'll solve an example. Calculate the area of the sector in the figure below, giving your answer to 2 decimal places. We have from the board a sector of a circle, as we said, bounded by an arc and 2 radii. So this is a sector with the angle subtended at the center to be 125 degrees and the radius at 4.2 cm. We know that area of a sector, the formula is given as theta all over 360 times pi r squared, where our theta is 125, our pi is 22 over 7, and our radius is 4.2 cm. Since we have r squared, it means r times r, so 4.2 cm times 4.2 cm. We divide through now. 7 into itself will give us 1. 7 here will give us 0.6. We have 5 here will give us 72. 5 here will give us 25. What else can we? What is left? We have 25 times 22 times 4.2 cm times 0.6 cm. And what if we have a 25 times 22 times 4.2 cm times 0.6 cm all over 72. All over 72. 6 here will give us 0.1. 6 here will give us 12. We have 2 here will give us 6. 2 here will give us 11. What's left? We have 25 times 11 times 6 here will give us 1. 6 here will give us 0.7. We have times 0.7 times 0.1. 25 times 11 times 0.7 times 0.1. And that will give us 19.25 meters squared. 19.25 meters squared. So our area of the sector is 19.25 meters squared. Now we are looking at real life activities that involves the use of areas. And we see that areas of shapes in and outside our homes, such as like our room floors, our football pitches, can be measured in centimeters and meters. But we have other units too that are more useful, like hectares of land, kilometers square. These are used in measuring large spaces. They are used in measuring large spaces. We look at the conversion units again, how to convert from large units to smaller units, and vice versa. We have a question on the board. A rectangular farm measures 3,850 meters by 1,050 meters. We have to calculate its area, leaving our answers in meters square, in hectares, and in kilometers square. So, we are told that the farm is rectangular in shape, and we know that the area of the rectangle is given as length times breadth. So, our length is given as 3,850 meters. We multiply by a breadth of 1,050 meters. If we multiply this through, we will get our area to be 4042500 meters squared. For 4,042,500 meters squared. That is the area of the farmland in meters squared. Area of the farmland in meter squared. Now, we are also told to calculate the area in hectares. We are also told to calculate the area in hectares. 1 hectare is A. The 1 hectare is the same as 10,000 meters squared. 1 hectare of land is same as 10,000 meters square of that land. So we now convert our area in meters square, 4,042,500 meters square, convert it to hectares. In doing so, we divide by 10,000. We divide by 10,000. Since this has 4 zeros, our point goes here 1, 2, 3, 4. So we have 404.25 hectares. 404.25 hectares. So our area of the farmland in hectares gives us 404.25 hectares. We now look how to convert it in kilometers square. So in kilometers square, we now convert our area in meters square to kilometers square. So we have 4042500 meters square to kilometers square. We have that 1 kilometer square is the same as 1 million meters square. And then we were taught that 1 kilometer is 1,000 meters. When we square it, the square of 1 gives us 1, the square of 1,000 gives us 1 million. So you have 1 kilometer square as 1 million meters square. For us to convert this to kilometers square, we now divide by 1 million. 1 million, okay, we divide by 1 million. 6 zeros. These 2 zeros cancel these 2, we are left with 4 zeros. We count 1, 2, 3, 4. That gives us 4.0425 kilometer square. 4.0425 kilometer square. So our 4,042,500 meters square, we will convert it to kilometer square. We have 4.0425 kilometer square. The same is applicable. If you want to convert this to our meter square, the same thing is applicable. 425. We count 6 zeros towards the right. 1, 2, 3, 4, 5, 6. And we have 4042500 meter square. So in conversion from a bigger unit to a smaller one, we multiply. But when conversion from a smaller unit to the bigger one, we divide. Now you take home this assignment. Okay, for your assignment, I will find the areas of the shaded portions. The shaded portions. These are the shaded portions for this. The shaded portion. And this one, this area is the shaded portion. And define the area of the shaded portion using pi as 3.14. Then we have, you have the smaller radius and the bigger radius here. The second one, we have to find the circumference of the circular pond is given as 10 meters. We calculate the area of the pond. The circumference of the circular pond is given as 10 meters. And we calculate the area of the pond. You know the formula for finding the circumference of the circle. You apply it to get the radius, then calculate the area. With that, we've come to the end of the class. I'm here to see your assignments. So I look forward to seeing this one as soon as possible. Stay safe, study mathematics at home, and see you next week. Goodbye.